Go.
In 1895, Wilhelm Conrad Roentgen discovered X-rays. In 1896, Antoine Henry Becquerel discovers rays produced by uranium, the first observation of natural radioactivity. Concerns first raised about possible injuries from X-ray exposure. Elu Thompson conducts experiments on X-ray burns. In 1898, Marie and Pierre Curie discovered that thorium gives off uranium rays, which Marie renames radioactivity. Marie and Pierre Curie discovered polonium and announced the existence of a new radioactive element they named radium. In 1898 as well, Paul Ulrich Villard discovers gamma rays. 1899, first malpractice lawsuit is awarded for X-ray burns. Ernest Rutherford discovers that radioactivity from uranium has at least two different forms, which he calls alpha and beta. Fritz Giesel, Antoine Henry Becquerel, and Marie Curie proved that beta rays consist of high-speed electrons. In 1900, Paul Ulrich Villard is the first to observe that gamma radiation is more penetrating than X-rays.
Okay, so I'm talking about beta. So Henry Becquerel, while experimenting with fluorescence, accidentally found out that uranium exposed a photographic plate wrapped with black paper with some unknown radiation that can be turned off like X-rays. Ernest Rutherford, who was the son of James Rutherford, a farmer, and his wife Martha Thompson, was born at Brightwater near Nelson, New Zealand. So Ernest continued Henry Becquerel's experiments and discovered two different kinds of radiation: alpha particles and beta particles. Beta particles are 100 times more penetrating than alpha particles. Beta particles are high energy, high speed electrons or positrons emitted by certain fission fragments or by certain primordial radioactive nuclei such as potassium-40. The beta particles are a form of ionizing radiation, also known as beta rays. The production of beta particles is termed beta decay. Beta particles are energetic electrons. They have a mass of 1/1840 AMU and they carry a single negative charge. Their path is not very straightforward. The beta particles follow a very zigzag path through absorbing material. This resulting path of particle is longer than the linear penetration into the material. Beta radiation ionizes matter weaker than alpha radiation. On the other hand, the ranges of beta particles are longer and depend strongly on initial kinetic energy of the particle. Some have enough energy to be of concern regarding external exposure. A 1 mega electron volt beta particle can travel approximately 3.5 meters in air. Such beta particles can penetrate into the body and deposit dose to internal structures near the surface. Therefore, greater shielding than in the case of alpha radiation is required. Materials with low atomic number Z are appropriate as beta particle shields. With high Z materials, the bremsstrahlung is associated. This radiation is created during slowing down of beta particles while they travel in a very dense medium. Heavy clothing, thick cardboard, and thin aluminum plate will provide protection from beta radiation and prevents production of the bremsstrahlung. Thank you.
Alpha radiation. Alpha radiation was discovered by Ernest Rutherford in 1898. Before the discovery of alpha and beta, a man named Becquerel had discovered a so-called uranium ray. Knowing of this uranium ray, Rutherford had conducted an experiment to measure an electric current created by the uranium rays. Rutherford in this experiment had a uniform layer of powdered uranium compound was spread on plate A, and the rays allowed to ionize the gas between plates A and B. The amount of ionization is measured by the saturation content received at B, or plate B, when the potential difference between plates A and B is great enough to pull all the ions to the plates before they are able to recombine. Rutherford then proceeded to cover the uranium with aluminum sheets of various thicknesses to measure the current using the electrometer. For this experiment, Rutherford had used the equation R equals EXP multiplied by negative lambda D, where R is the ratio of the intensity of the radiation passing through the distance D of the substance to the intensity where the substance is removed. An easier way of understanding this is I equals IO multiplied by EXP multiplied by negative lambda T, where IO being the current with nothing covering the uranium on plate A. I is the current at each thickness, which is called T. With this, Rutherford had predicted that lambda was going to be the coefficient of absorption if the uranium rays were homogeneous. Then lambda would remain a constant as T is increased and as I goes down. Although this was not the case, Rutherford had instead found that lambda stayed a constant for a few hundredths of a millimeter of aluminum, or for a few centimeters of air, covering the uranium plate A, and then suddenly dropped to another value, where it remained as the thickness of the aluminum layer was increased. So he concluded that there were at least two parts of this uranium ray. The easily absorbed ones he named alpha, and the more penetrating ones he named beta. And there's a diagram of the experiment and the equations.
Alright, I'm doing X-rays. So Wilhelm Conrad Röntgen was born March 27, 1845 at Lennep in the Lower Province of Germany. During 1895, Wilhelm was working with a cathode ray tube in his laboratory. He evacuated the tube of air, filled it with special gas, and passed a high electric voltage through it. When he did this, the tube would produce a fluorescent glow. Wilhelm shielded the tube with heavy black paper and found that a green-colored fluorescent light could be seen coming from a screen setting a few feet away from the tube. He realized that he had produced a previously unknown invisible light or ray that was being emitted from a tube, a ray that can pass through the heavy paper covering the tube. Through additional experiments, he also found that the new ray would pass through most substances, casting shadows of solid objects on pieces of film. He named the new ray X-ray because in mathematics, X is used to indicate the unknown quality. In discovery, Wilhelm found that X-ray would only pass through tissue of humans, leaving the bones and metals visible. One of Wilhelm's first experiments was in late 1895 on his wife Bertha's hand with a ring on her finger.
I am doing gamma radiation. In 1900, a chemist and physicist by the name of Paul Villard discovers gamma rays when he was experimenting with radioactivity, and discovered a new ray that had a high penetration depth and was emitted from radioactive substances and not electric or magnetic fields. Paul Villard distinguished X-rays and gamma rays by seeing that gamma rays have a higher penetrating depth and that gamma rays come from the nucleus. Gamma radiation is a form of electromagnetic radiation, or EMR. Gamma has also the highest energy in the EMR spectrum. Gamma radiation also has the shortest wavelengths. A little more information on Paul Villard. Villard was born in Saint-Germain-en-Mont-d'Or, Rhône. He graduated from the École Normale Supérieure in 1881. Paul would maintain a laboratory position at the École Normale Supérieure until his retirements. At the time when he discovered what we now call gamma rays, Villard was working in the chemistry department of the École Normale Supérieure de Lyon in Paris. Villard is also credited with the discovery of argon hydrate, which he spent the early part of his career focusing on similar compounds at high pressure. Thank you for watching this video and have a wonderful day.